Okay guys, so I am going to work through the study guide. I'm going to try to do every single one to make sure you guys are good, but if I notice that some problems are similar, I might skip those problems, okay? So let's start with number one. Number one has 24, and you guys should have your study guide in front of you. If not, I have a blank key on eClass. Okay, so number one reads 24 plus v is equal to 133. It says to solve the following equations. By solve, I mean find what the variable is. So here's my variable, and remember I told you guys this is kind of always like a brick wall, right? So we're never concerned with the number that's by itself. It's always the number that's attached to the v, okay? 24 is on the same side as v. So what I need to do is get v by itself, okay? That's my goal. So I'm going to look at 24. And in order to get it by itself, I have to use the inverse operation of what 24 is. 24 is positive. So in order to get it away, I'm going to use the opposite. So minus, a negative, right? So if I minus 24, I'm going to do that on both sides. If I do it on one side, I'm going to do it to both sides. So just make sure, guys, I think that we kind of get lazy and we don't add our operations and we forget what operation we use. So don't do that. Make sure you clearly write minus 24 on both sides. So here I get positive 24 minus 24. I'm left with just 0, right? That cancels out and I'm left with v. So I'm going to bring down v and I'm going to rewrite my equal sign. And 133 minus 24 is actually 109. Okay, that's actually my answer. The way I could check it is plug in 109 for v. So 24 plus 109, is that equal to 133? If that's true, then you did it right. Okay, so let's do number two. Number two is w minus 99 is equal to 630. Okay, so again, we're going to say that these are two separate sides, right? So you can ask yourself what number is attached to w, and that is 99. So we need to use the inverse operation of 99 on both sides. 99 is negative. So the way we do this is we always refer to the operation or the symbol that's in front of that number. In this case, it's a negative sign. So what I want to do is I want to use the opposite. So I'm going to add 99 to both sides. Again, don't be lazy. Show me 99. And then I should get 0 on this side, so negative 99 plus 99 gives me 0. If I'm in debt, meaning I owe $99, but then I pay 99, I'm not in debt. I'm left with $0. So I bring down my equal sign because I've isolated w. That's my goal. And then 630 plus 99 gives me 729. Again, you guys can check this by plugging 729 in for w. Okay, let's move on. Okay, let's look at number 3. So guys, before I can start, I need to go ahead and kind of convert into my mixed numbers into improper fractions. So I'm going to rewrite it and then I'll erase that top part. So m plus, this is how we do this, 8 times 4 gives me 32. 32 plus my numerator is 39. So 39 over 8 is equal to, same thing here, 13 times 4. That's 40 plus 12, that's 54. I'm going to confirm that. Oops, 13 times 4, I was right. Nope, I was wrong. 52. So 52 plus my numerator is 53. So that becomes my new numerator. And I keep my old denominator. So before I can go ahead and isolate m, in order to get rid of 39 over 8, since it's on the same side as m, I need to make these denominators the same. So 8 and 4, I can use 8 as the denominator because that's the least common multiple between these two. Okay, so I can multiply 4 by 2 to get 8. So if I rewrite this, sorry, I'm running out of room, I get 8 on the bottom. But whatever I multiply on the bottom by, I need to multiply the top by as well. And I should get 106. Okay, so now this is something that's kind of looking like I can isolate and figure out the fraction, right? Or figure out what the variable is. Oh, sorry. Okay, so I'm going to erase this top part and I'm going to rewrite the equation we got at the bottom, okay? That way we're a little bit neater. M plus 39 over 8 is equal to 106 over 8. Now we can solve for m. So now this is looking like something we know, all right? So 39 over 8 is positive or negative? That is positive. So that means I need to use the opposite to get it by to get m by itself. So I'm going to subtract the same thing. Subtract 39 over 8. That cancels out. But now I need to subtract 39 over 8 on this side. Here I'm left with m. I carry down my equal sign. 106 minus 39, 67. And then I keep my denominator. Here is my improper fraction. So what I'm going to do is now I'm going to take this and convert it back to a mixed number. 8 goes into 67 8 times. That's 64. There's 3 left over. And then I keep my old denominator. So it's 8 times. 8 goes into 67 8 times. That's 64. 64 to 67 is 3. And then I keep 8 as my denominator. Okay? So my answer would be 8 3/8. Okay, let's move on to number 4. So number 4 reads 0.99 is equal to m minus 6.7. Now, the way I would do this is the same way. However, our m is now on the opposite side, which is okay. So m is on this side, and 6.7 is actually negative, so that means that I need to use the inverse operation of addition, 6.7 on both sides. Okay, here this cancels out, so I'm left with m. Bring down my equal sign, is equal to. So what I'm going to do is 0.99 plus 6.7, and I get 7.69. Okay, so I can again plug this in for m and see if it works. If it equals 0.99 on this side, that is a true statement. 0.99 is equal to 0.99. Okay. So my next one, number 5, reads 8x is equal to 4,032. Okay, so this one is different because in order to get x by itself, I have to use a different operation. So if I told you, oops, sorry, if I told you that if I have a number next to a variable, that means that that's actually a product. So this is a multiplication problem. So in order to take the inverse or the opposite to get x by itself, I'm going to have to do the opposite of division. So if this is multiplication, I'm going to divide by 8 on both sides. This cancels out to 1, so I can carry down my x and my equal sign. And 4,032 divided by 8 gets me 504. You can plug 504 back into the equation by doing 8 times 504, that equals 4,032. You are good to go. Okay, let's keep moving. Number 6, I have 0.5, x is equal to 75. Okay, this is the same story as number 5, the one we just did. Just because it's a decimal doesn't mean anything. It's still a product, it's still a multiplication problem on this side. Okay, so I need to use division, that's my inverse operation, and I need to divide by 0.5 on both sides. So this part cancels out, so I'm left with just x. I'll bring it down, same with my equal sign, and then 75 divided by 0.5. Oops, sorry guys, I need to confirm. Gives me 150. So you can do that by confirming 0.5 times 150 gives me 75. Okay, so let's move on to number 7. I have 0.9 or 0.09. M is equal to 81. So I want to isolate M. Again, this is the same thing like number 6. So I want to take the inverse of multiplication. So that's division on both sides. And I'm going to divide by 0.09. Okay? So it will always be the number that's somehow attached to M, whether it be multiplication, division, or addition and subtraction. Okay? So this becomes a 1 that cancels out. I'm left with M. Bring down my equal sign. I got to divide by 0.09, and I get I believe 900. Let's confirm. Yep. Okay, so M is equal to 900. So again, you can plug that back in and do 0.09 times M, which is 900. You should get 81. That is a true statement. Okay, let's move on to number 8. X over 4 is equal to 16. Now this is something different, alright? So this side, we're going to do the same thing by isolating x, but we're going to do a different operation, a different inverse operation. So if this is division, because a fraction is also a quotient, or it's a division problem, I'm going to do the opposite of division, which is multiplication on both sides. So the only other number that's on this side is 4. So it's attached to x. So I'm going to multiply by 4. 4 is also written as 4 over 1. Which is why I actually have 4 over 4, which cancels to 1. So I'm left with x. So I'll bring that down with my equal sign. Multiply that side by 4. I get x is equal to 64. Okay, you guys can confirm this by saying 64 divided by 4 gives me 16. Alright, number 9. 12 is equal to 5 over 12 m. Guys, so if you want to rewrite your problem with the variable on the left side, you can totally do that. And I prefer that because it's easier to isolate that way. So I'm going to rewrite this with the variable on the left side. Okay, so now if we have, this is a multiplication problem, so if we have a multiplication problem, but my coefficient is actually a fraction, the way I would get rid of it in order to make it 1 is to multiply by the inverse, or multiply by the reciprocal. So if I multiply 5 over 12 by 12 over 5, this cancels out. 12 divided by 12 is 1, and 5 divided by 5 is 1. So 1 divided by 1 is still 1. So again, I don't need to write 1 right here. That's the implied coefficient. I know it's 1. So you've isolated m. So I got to do the same thing here. So I got to multiply 12 by 12 over 5. I'm going to bring down my equal sign. So when I do this, 12 times 12 is 144. I keep 5 because 12, a whole number, is also 12 over 1. That's how it could be written as a fraction. Okay, so 5 goes into 144 28 times. And there's 4 left over, and I keep 5 as my old denominator. Okay, so my answer is 28 4/5. Let's move on. Okay, so now we're going to use substitution to determine whether the given number makes the equation or inequality true. So we have to prove our answer by solving it. So our first one, number 10, says y over 3 is equal to 37 if y is 111. So if I plug in 111 for y, I'm going to solve this. 111 divided by 3 is equal to 37. 37 equals 37. This is a true statement. They're the same numbers, so yes, 111 does work. Okay, so let's move on to number 11. Number 11 says 0.5 x is less than 12 if x is 24. So let's see if this is true if x is 24. So guys, remember I told you this is actually a multiplication problem. So when I write this out, I actually write 0.5 times, or you can use the multiplication symbol, that's fine, x, which is 24, less than 12. So I'm going to go ahead and multiply 0.5 by 24. I get 12 is less than 12. This is not a true statement. 12 is not less than 12. 12 is equal to 12. Okay? So that is false. That is not a true statement. It should be equal. Okay? In order to make that a true statement, I could put the or equal sign, and that would be true. However, in this case, we do not have that sign at the bottom. So this statement is false. It is equal to. Okay, number 12, 9.4 is greater than m minus 3.2 if m is 15. So I'm going to plug in 15 for m. 9.4 is greater than 15 minus 3.2. So 9.4 is greater than 11.8. Okay, so is 9.4 greater than 11.8? That is false. The answer is no. That is not a true statement. 9.4 is less than 11.8. So this does not work. So 15 would not be a possible solution. All right, so let's move on to number 13. Number 13 says we need to write inequalities to describe the situations, and we need to define our variable. So number 13 says you must be at least 54 inches tall to ride Batman. So we will always, when we have inequalities, we're always going to have an x and the number in question. So in this case, it's 54. So now I have to make a symbol, an inequality symbol. I have 4 inequality symbols. Less than, greater than,